This really is next generation technology. We have the ability to measure the mountain snowpack to an accuracy that has never before been possible. At Airborne Snow Observatories, or ASO, we map snow depth and snow water equivalent at high resolution and high accuracy across entire mountain watersheds. This gives us a really accurate inventory of the mountain snowpack and allows us to understand what our snow water supply looks like and help out with water forecasting.
So the snowpack is really important here in Colorado because the majority of our water in Colorado that we use every year originates as snowpack in our high elevation watersheds. So being able to measure that with this ASO technology gives us a better idea of how much water we'll have throughout the entire year for residential users, for agricultural users, for recreation, for fishing. And so it all really originates as that snowpack.
We fly a twin-engine aircraft. Typical flights last 3 to 6 hours or so, back and forth, basically mowing the lawn across the watershed. Our aircraft have 2 instruments on them. The lidar shoots beams of light at the snow surface, measures their elevation to give us the snow depth, and the spectrometer measures how much solar energy is reflected by the snowpack. From that, we get a snow depth every 10 feet throughout the entire watershed, and it really gives us that complete picture of what the mountain snowpack is doing.
This year is really exciting because we're both doing the most number of flights we've ever done in Colorado, and we're also flying some areas for the first time ever. So it's the inaugural flights in the Upper South Platte watershed, Northern Front Range, as well as in the Roaring Fork watershed. So the main benefit of ASO is that it provides the most accurate measurement possible of how much water is actually in the snowpack in our watersheds. And having that measurement as water managers provides us with unparalleled confidence to make the best use of that snowpack as it makes its way through our watersheds.
So we still use a lot of techniques that were developed even in the 1910s to monitor our mountain snowpack. ASO builds on that capacity to add a new spatial perspective. So on a typical field day, and we're aiming to supplement our airborne data, we'll ski out to a location that is relatively undisturbed, and we'll mark out an area and dig to the ground, and then make measurements throughout the profile of the snowpack. And that tells us what the water equivalent is, what the snow density is, what the depth is, and then also what the temperature profile of the snowpack is.
37.
So we rely on manual measurements and station measurements that are maintained by our federal partners, and we add this new basin-wide perspective that allows us to get a complete snowpack volume and really dial in our runoff forecasting.
ASO is an important climate adaptation tool because really climate change has a direct impact on how the snowpack develops each year and over time. Denver Water started using this technology a few years ago, and we really found a lot of benefit in how it helps us make water management decisions. And so what we've been doing is building this partnership program called the Colorado Airborne Snow Measurement Program, or the CASM program. And this is really a partnership program to create this statewide coordinated effort and create that consistent data set year over year.
We're so psyched on what we're doing because the technology's cool, we all love snow, and we feel like we're making a difference. We're really helping us as a society better understand what our mountain water resource is doing.